Hey there viewers, welcome back to Ray of All Trades. Next we're working on a Stihl MS270. The complaint is that when they put it in stop, it doesn't shut the saw off. They have to basically flood it out. Let's test it out, verify the complaint, and then let's tear into it. So, had a hard time keeping it started and running, but we were able to prove that when we put the stop button off of the master switch into the stop position, it wouldn't shut off. The stop circuit on these is actually pretty easy. I'll show you. Oh, it's dirty. Real dirty. Part of why it's not running right. There is a piece of metal right here that's connected to a wire. This little brass piece right here, you'll see that, connects to this piece of metal right here. This piece of shiny piece of metal, this silver looking piece of metal, connects over to a coil over here. Fairly confident our problem is right here. One of these two wires is has broken off of that copper part. But let me take this off just so I can show you guys what it connects to. Alright, so when those two pieces of metal connect together, what you're doing is you're connecting this black wire to this yellow wire through that switch is all you're doing. And the black wire goes into the coil to shut the coil off, and it does so by grounding it out. So this yellow wire is actually attached to the metal of the frame. It's called common, ground, whatever you want to call it. All you're doing is connecting this to this. So if you ever disconnected, let's say, just pull this wire right here off, or that wire off of there, the saw would never shut off. It'll just keep going and going. You have to have, that has to make a connection to there to shut the spark off, and which actually kills the saw. So flooding it out is not a great way to do it. So what you can do is put an ohm meter between these two points of contact and move this switch right here to the off position. And if it makes continuity, then you know you got a completed circuit. So we can try that. I'll show you real quick. All right, makes a connection right there. So one of them is on this yellow wire. Let's put one there and one there. Making contact, goes away. Alright, what I was supposed to show you is I've got one connected here. So basically we agree that this yellow wire connects over to this motor. So I got a good connection there. So in the run position, there's no continuity here. There's no continuity there, right? If I put it to the stop position, I should have continuity. Now it looks like we must have had some dirt or whatever, because what I was going to show you is that flipping that switch up made no connection at all. And now we have a good kill switch. Got a lot of dirt, debris, everything else. I'm going to clean the saw up. Very likely just the corrosion that was on top of here, or dirt that was making a bad contact right here. Because I haven't tightened that bolt yet, but I did take this off and put it back on, and it should have fixed the saw. So anyhow, right now, if I put it to the kill position, this saw won't have any spark at all. The spark on it would actually be dead if I did that. Anyway, that's the troubleshooting method. Unfortunately, I fixed it before I even had an opportunity to look. Let me pull this cover off because I really want to show you guys how those wires connect. This thing's in need of a cleaning. So the yellow wire that came from up here travels down around the motor, comes out this grommet here, goes up to this piece of metal, this spring. A lot of times this spring will lose tension or wear out. I've actually seen them broken off all the way from here up. So that wire there runs to this spring, connects up through here, and then the black wire connects down to this piece of metal right here that goes into this ring. There's a metal ring right here that is connected to this round part. Can you see that, I hope? Anyway, so basically we're making a connection through here to kill the motor up through those wires to that coil. You at least know how it works. I'm going to put the air filter and stuff back on here so that I can go clean this up with some compressed air and get a lot of this stuff out of here. And let's check and see if that's enough to fix it or if there's something else going on. Cleaned everything up, just blew off a lot of the dust. I used a pick and whatnot and got a lot of dirt out of around the flywheel and everything. Put all that back together. Like I said, it wasn't running very well. I believe that the fuel could have been a culprit. It didn't smell great, so I'm going to put fresh fuel in it, and I'm going to adjust the carburetor. And I've tried to talk over it before and it didn't work so well. What I'm going to do is this hole right here, right there, that one's the idle speed. So I'm going to turn up the idle speed a little bit, about 3/4 of a turn. I expect that that will keep it running, but it's actually going to be running a little bit fast once I get everything adjusted. Then you have two adjustment screws right here. They have limiter caps on them. It's a newer saw and nobody's pulled the limiter caps off yet. So the back screw is labeled H and it says 3/4 of a turn. What that's saying is if you took this and turned it all the way till it stopped, not bone crushing, just gently till it stopped, and then you backed it out, they're expecting it to come out 3/4 of a full rotation. Then on the low speed screw, which would be your idle screw, this one they're expecting it to be 1/4 of a rotation from at the bottom. Now it has, like I said, limiter stops on it. The limiter caps have been removed. Very likely this would be 1 full turn, and this would probably be 1 full turn. Would be a good place to start. Generally, it's going to be somewhere between 3/4 and 1 1/4, something like that. And that'd be a good place to start. But the idle speed screw is the one that you're going to adjust till the chain is moving or it idles at its maximum speed. And once it does maximum speed, so you're going to go clockwise and counterclockwise. Clockwise is leaning it out, in other words, removing fuel. Once you've got it adjusted for maximum, I always like to turn it back about 1/8 of a turn, richen it up just a little bit. The high speed screw is set with a tachometer. You want it to be set for whatever the RPMs are supposed to be for the saw. A lot of people, including myself, like to adjust them by ear. What I look for on a good adjusted saw is when it's running and it's not in wood, it makes a 4-stroking sound. It's a burble, a hiccuping sound, a burr, 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 you know, as it's running wide open speed. That helps the saw run a little bit cooler. Once I think that I've got a really good throttle response, everything works like it's supposed to, and it's just running too fast, at that point I'm going to turn the idle speed down to where the chain just stops moving. That's where I like to leave the saw. That's what I'm getting ready to set. I'll have it on camera and you'll probably see me doing it, but I won't be able to talk to you during that time. Let's get this thing gassed up and give it a try. Making sure that the bar is oiling as well. Well, friends, brought it back to the bench. I didn't expect that one. Idle RPM on this thing says it should be right around 2250 or was it 2400, something like that. The wide open should only be 13.5, and this thing keeps peaking at 14,000, somewhere in there. I got it as rich as I could, and it was still running quite up there. It did sound a lot better, but I didn't like it. It just sounded fast to me. So I kept checking and kept checking, and that's why I went back several times. What I noticed is that even though we've ohmed this out and this works like it's supposed to in the shutoff position, it doesn't shut off until I actually push down on the tab. It's not the wire, it's the actual tab itself that goes into the coil that's causing me a fit. Now, I'm fairly confident that this coil has an RPM limiter. I could be wrong, and very likely I am. If y'all know, comment down in the section. This coil itself is suspect for a couple of reasons. Like I said, it's running pretty hot. I cannot get the chain to stop spinning. I'm fairly confident that's just dirt in the clutch that's causing that. But the fact that I have to push onto the tab to get this thing to shut off, and knowing that that's a circuit board inside there, you can even see it. I'm gonna say that this thing probably needs a coil. Let me get this thing off and take a peek at it and see if there's anything that's obvious to me. Let's see if I have one that matches up with this. The used one, to see what it does. Okay, I didn't have a spare ignition coil that fit this. It looks like this tab, it was definitely bent when I first got to it, and it seems like it's got a little bit of play. I almost want to dig out this epoxy and solder it back in, but I'm going to try an aftermarket coil, see what that does. I know this coil runs, it just doesn't shut off. Let's get this coil. It says it'll be here tomorrow. Let's see what happens. All right, let's try to see why this clutch was grabbing hold prematurely. It should have, at those RPMs, it should have allowed that chain to stop. A couple things can cause it to do that. Number one is a bent crankshaft, but most likely it's just got some dirt built up in here. Let's take a peek and see what's going on. The first thing is this band around the outside. That's the brake. That's what's preventing it from turning. So you can release the brake, and you can see the band over there. And let's pull off this E-clip. They usually come off pretty easy. This one's fighting me a little bit. There we go. And then the keeper, and your drum sprocket. And yeah, it's got a lot of dirt inside the drum itself. And right here is the reason why it's not letting go. So see this spring right here? That spring is broken. It's supposed to look like this. So basically this clutch is actually always engaged. The spring pulls it back together. Centrifugal force forces it apart. So this spring right here is what's keeping it from retracting. That's going to keep the chain constantly moving because it's always grabbing, and it'll wear out that clutch prematurely. We'll pull off the bearing. We're going to order a brand new clutch. I probably could just get away with putting another spring in from an old clutch, but I got to take it apart anyway. Might as well try to grab a clutch at the same time. So that's why the chain was continuing to move. A combination of dirt and broken spring allowing the clutches to come apart. You can do a couple things. You can stop the piston by putting a piece of rope in there and fighting against it. But anyway, the clutch comes off reverse thread. Generally, I just put a impact on here and just give it a couple little hits with the impact. You know, a very light duty impact, not one you take card lugs off with, but a light duty impact, and it'll usually pop this loose. I'll meet up with you guys as soon. Welcome back, everybody. Parts arrived. Got an aftermarket clutch. So it came with new bearing, new keeper, new plate for behind it if they're worn out. A lot of times they'll wear out on the center. It also came with a new E-clip. Not terrible. Also got a Chinese ignition coil. It's pretty close. So there's a couple ways to take this clutch off. I think I was telling y'all before. You can pull the spark plug and you can put a piston stop in there, which is it looks like a bolt with a dimple on the end of it, or a nipple on the end of it, that actually stops the piston from moving. Because as this is turning, that piston's moving up and down, and that'll stop it. The other thing you can do is you can take like 550 cord or some rope or whatnot that fits down inside that piston. Just be careful that you're not pushing it through the exhaust or in the intake, and you can bind it up and then use a wrench. This is reverse thread, so it does come off going clockwise. A lot of times what I try to rely on, and has most of the time worked for me, is just leaving the spark plug in so that I have compression, and then I use the impact to pull it off of there. And the impact itself is not really hitting anything because it's using the gas as like a buffer, so which will also prevent it from coming off a lot of times. So this battery on this impact is somewhat dead, but let's give it a try. Put it in forward gear. There we go. Came off fairly easy. Yeah, got a lot of hot spots on it, and specifically where the spring was broken, it seems like it's got a lot more wear right there, which would make sense, right? There's the plate behind it. The plate's actually still pretty decent. It's not worn out in the center. It seems to still fit there. There's a wire right here that happens to be your oiler, so when you put your drum cover back on, it's got a groove in here that's going to line up with that arm right there. And that right there is your oiler drive gear. So as the clutch is spinning, it's turning this gear right here, which is attached to your oil pump. Then your oil pump hoses are here and here. This one here down here goes to the tank. This one up here comes out of that hole right there, which feeds oil to your bar. Anyhow, more information y'all probably wanted, but figured I'd take the opportunity. So just do that. I'm going to tighten it up going counterclockwise. So generally that's enough because it tightens up as it's turning. When you go to put this drum cover back on. I'm actually going to reuse this bearing because it wasn't in terrible shape. Just because this is a factory bearing and the other one's aftermarket, I'm not sure of its quality. This right here literally is just attaching your motor to the chain. So if this gives up the ghost, we'll just swap that out. But if I start adding inferior products, which I'm not sure that they are, I'm just more concerned about it. So let me put a little bit of grease on here and we'll put this drum back on. And I try to leave it as factory as possible because I mean the original equipment on these was pretty good. Saving money on the parts that I know are broken. A little bit of grease there. Let's get some of this dirt cleaned out of here. And like I said, I'm looking for that arm, that oiler. Looks like it's over here, so I'm going to try to line those two up. And if it lines up, it'll drop in there. If it doesn't line up, it'll stay pushed out. And the keeper goes on like that. And then the E-clip goes on. There we go. Good enough, right? Here was the old coil. Here's the replacement coil. Yeah, pretty okay knockoff, I guess. Just line up the holes. The one down there just gets the bolt and washer. The one up top is bolt and washer and then goes through the ground wire. We're just going to snug it up just enough to where it just touches because I still need it to move. Loosen those up a little bit. Take my business card, pull the coil up away from the flywheel, put the business card under those pieces of metal, and then put the magnet back in the center so that it pulls towards it. Push down on the coil to kind of squeeze the business card. Snug those down. Some people like to put a little bit of red Loctite on there or blue Loctite preferably so that it'll come off again. Get my kill wire, because this is really your ground wire. This right here would be effectively your kill wire. That's how it goes together. What I should be able to prove even before we bring it outside. See if I can get you guys close enough to see it. See, you got spark there. I'm hoping you can see that. All right, and if I put it to the kill position, no spark. Back to the run position, spark. So we've proven that the kill on the coil is working properly. This hole right here is my oiler hole. I want to make sure that that's clear and I can see chain moving inside it. And it is. Make sure I'm inside my clutch sprocket. Make sure the teeth are going the right direction. This is my adjuster hole. And then, like I said, my oiler hole was back there. We already checked that. Make sure it's seated on there properly. It did. Push the bar or the chainsaw forward so that the bar is against the table. Give it some slack. Feels like it's too tight. Okay, rotate it forward so I have all the play. Snug it up until it just touches. Tighten it down. Alright, let's see if we can get this thing to run and tune up properly now. Alright, I'll meet y'all outside. Let's go cut some wood and see what it does. Battery died just when I was finishing up my last couple cuts, so I'm not sure what's going to be on the video. Anyway, MS270, looks like some of the gas that was inside it was no good, and the clutch and the coil, kind of an easy one. Hope you guys got something out of the video. Hope you enjoyed it. I'll catch you guys on the next one. Thanks for everything, guys. Appreciate y'all.